number 2, we have which species below is amphoteric according to the Brønsted-Lowry acid-base theory. All right, so amphoteric means a species that accepts a hydrogen proton or gives away a hydrogen proton. All right, so it's kind of dual. It can give away or it can take on. Give away or take on. So a lot of the examples they might give you in these multiple choice type questions are situations where they can only take or they can only give away, but we need to look at species that can do both. All right, and so you definitely want to look at something has to have an H, right, to taking. Well, it has to have an H to give away, right? It needs to have a hydrogen proton to give away. So that's pretty that's what I would look for, you know, when we're looking at options A through B here. Now BR, for instance, A, it can take on a hydrogen proton, but it clearly doesn't have a hydrogen proton to give away, so I'm going to put a big N for no. Option B, we have an H attached to an SO4 to the sulfate anion with a minus charge. So this was most likely H2SO4 that already lost one hydrogen proton, but guess what? We could actually lose another. And we could also gain. We could also gain to make H2SO4. So this is a very, very good candidate. I would just put a yes here. But it's always good to, you know, scan through the rest of the options, make sure you didn't miss anything. And so with part C, H3O plus, that's our hydronium cation. And clearly we could give away a hydrogen proton here, but we can't take one on. We don't have H4O plus plus. I don't know. I'm guessing that probably would not be a stable species. But yeah, that's not a road we want to go down. That's not an option here. I'm going to put no for that. Now, part D, we have ammonium anion. I was thinking it was hydronium again. It's our ammonium cation. The ammonium cation can only give away, okay? It can give away to become NH3. But can it take to become NH5? No. Not likely, not a stable compound. I would rule that out right away. So if you add a hydrogen proton and it ends up being something you've never seen before, or you can even search it online and say, hey, no, that's not going to be an option. That's another way to tell. E, part E doesn't have a hydrogen to give away. That's our carbonate anion. We could, of course, take one on and become bicarbonate, but we cannot give one away. So that one's definitely a no. D is definitely no as well. Let's go with B. We can go with that hydrogen attached to the sulfate, and we can say that it's amphoteric.